Okay, so this is our KB homework stuff, which is on page 407. So let us start working on these. These are very similar to our KA calculations, just very minor differences. And we'll do a couple with the ice table, and then we're going to skip the ice table. So molar concentration of ammonia is 0.105. This is actually pretty much almost the same question we did in our class notes. Ammonia plus water gives ammonium plus OH minus 0.105, 0 minus x plus x plus x, 0.105 minus x, x. I have to calculate the pH. I can find my KB from back of the textbook. Let's see, KB of ammonia is 1.8 times 10 to the power negative 5. So first things first, I'm going to do 0.105 divided by KB greater than 500, justified. Get that off. KB is x squared divided by 0.105. And I know KB is 1.8 times 10 to the power negative 5 equals x squared divided by 0.105. So to calculate x, I'm going to multiply 1.8 times 10 to the power negative 5 times 0.105, take square root of that. There we go. X equals 1.37 times 10 to the power of negative 3, which is my OH minus. Then I do negative log of that to get my POH, which is 2.86. Again, negative log of this value. And then I do still have to find my pH, so I have to do 14 minus that answer. pH is 11.14 for ammonia, and that makes sense. So hydrazine is rocket fuel, concentration, calculate pH. The exact same question. So I will do, again, initial concentration. What is KB of hydrazine? 1.3 times 10 to the power negative 6. So I'll do 5.9 times 10 to the power negative 2 divided by KB greater than 500, justified. And you can see how I'm just modifying this calculation. I'm going to get the same idea anyway. So KB I found was, what was it again? 1.3 times 10 to the power negative 6. KB equals x squared divided by 0.0159. Right? And I get x here equals 1.3 times 10 to the power negative 6 times 0.059 square root is my OH minus concentration, 2.77 times 10 to the power negative 4. POH is negative log of that. It's 3.55. pH is 14 minus that. Oops. Okay, go back. 10.44 is the pH for this question. And just to see, I just did the exact, I would have done another ice table, I would have done the exact same thing, but I always get K value equals x squared divided by initial concentration after I do the justification. My x is either OH minus, in this case it's always OH minus, but it could be H3O plus for our Ka for the last video. And then I go negative log, gives me POH, 14 minus gives me pH. So it's very repetitive, so to speak. Sorry. So now we're going, this question is the other way around. So we have to do, we're given the pH, we have to find KB. So let's do one of those questions. So from the pH, I can calculate my POH. which is 14 minus 9.93, which is 4.07. And now my OH minus concentration is 10 to the power of negative of that, which is 8.5 times 10 to the power of negative 5. Now I have to calculate my Kb, right? So my Kb value, I need a nice table first, so instead of writing the full formula, I'm just going to use morphine plus water gives me morphine H plus OH minus, right? So the H plus is attached to the morphine here. Here my morphine was 0.0045 minus X, 0.0045 minus X. So what is 0.0045? Oh, well, we'll do this. 0 plus X, X, but I know X as OH minus concentration to be 8.5 times 10 to the power of negative 5. So this is also 8.5 times 10 to the power of negative 5. And this is 0.0045 minus that, which is 4.41 times 10 to the power of negative 3. Is that right? Yeah, that's right. Okay. Now my Kb, I do 8.5 times 10 to the power of negative 5 squared. So this times this divided by 4.41 times 10 to the power of negative 3, which is 8.5 times 10 to the power of negative 5 squared divided by answer. Kb should give me 1.636 times 10 to the power of negative 6 is my Kb. Boom, done. Methylamine, fishy smelling gas. That's funny. At room temperature. Prescription drugs using methamphetamine. Cool. 0.25 aqueous solution. So calculate OH minus POH. Okay. I know Kb of methylamine from my thing is 4.6 times 10 to the power of negative 4. I do 0.25 divided by Kb greater than 500, justified. And so automatically my well, I'll write my expression. Kb is 4.6 times 10 to the power of negative 4. There's no room here. I'm going to rewrite it here. 4.6 times 10 to the power of negative 4 equals x squared divided by 0.25. This is very similar to the first two questions that we did. I could draw a nice table, and you can draw one if you want to, but you will end up with this expression in the end. So I'm going to multiply by 0.25, multiply the Kb by 0.25, take the square root of that, x equals 0.107, so this is equal to OH minus concentration, and so I take negative log of that to get my POH as 1.97. Okay. So here, the only extra thing that I have to calculate is my percent of molecules that react with water. So this is basically my percent ionization, but for a base. So triethylamine, calculate OH minus. Okay, so that's again straightforward. I'm going to do Kb of triethylamine. Look at the back of the book. Where's triethylamine? Right there. 6.4 times 10 to the power of negative 5. Back of the textbook. So now I'm going to do 0.22 divided by Kb greater than 500, justified. So right away I can say 6.4 times 10 to the power of negative 5 equals x squared divided by 0.22. X equals OH minus concentration equals 6.4 times 10 to the power of negative 5 times 0.22, take the square root. 3.75 times 10 to the power of negative 3, which is OH minus concentration. Now calculate percent of molecules, percent ionization. I will do just the X. So percent is OH minus concentration divided by 0.22 times 100%. Just like we do H plus concentration divided by initial concentration of acid, I'm going to do this divided by 0.22 times 100 is equal to 1.7% molecules that react. Well, moles that react, same thing. Okay, what is the concentration? So we'll try doing a nice table for this one, just because it's another kind of question. This is very similar to the last questions of the Ka calculation part. So we have initial concentration, which we'll call C, we don't know, minus X, C minus X, 0, 0, plus X, X, X. pH is 10.5, so POH happens to be 14 minus 10.5, which is 11, so 3.15, and OH minus concentration, which is incidentally equal to X, is equal to 10 to the power of negative POH, 10 to the power of negative 3.15, 7.07 times 10 to the power of negative 4. Sorry about all the mess here. There we go. So that is our X value, right? So then we have our Kb of ammonia from before. Kb from textbook is 1.8 times 10 to the power of negative 5. And that is equal to X squared, so 7.07 times 10 to the power of negative 4 squared, divided by C minus 7.07 times 10 to the power of negative 4. So I'm going to do some arranging in my head. I have room over here, so I'm going to just continue that over here, arrow. So I'm going to move this up here and move that down there, just so that I have C minus 7.07 times 10 to the power of negative 4 equals to 7.07 times 10 to the power of negative 4 squared divided by 1.85 times 10 to the power of negative 5. So that is, this entire thing is equal to squared divided by 1.8 times 10 to the power of negative 5. There's no 5 over here, just 1.8. And this thing gives me 0.0278. To that I'm going to add 7.0 times 10 to the power, 7.07 times 10 to the power of negative 4, which gives me 0.0285 is my initial concentration of ammonia. Woohoo! Okay, we're done. Excellent job, everybody. I will see everybody in class. We're gonna do buffers and salts and titrations and all that fun stuff. So yeah.